Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. And in this video, we're going to be working on that assignment 3-2, which is that arc length and sector area. So what we're doing is we're taking, a normal circle, find that radius, find whatever that angle amount is, theta, and we're trying to find that arc length. And so we're talking about, part of that circumference. Or if we're talking about the area of a sector, we're talking about, that shaded inside amount. So always working with those circles, make sure you can think of pizza. So when we're talking about the arc length, we're talking about the crust. However, if we're talking about the area of a sector, we're talking about the actual slice. So in that first one, it says number 1, find the length of HI. And so we're talking about this length here from that curved part HI. So what's going to be our radius? Well, it has in big letters, R is going to be 8, theta is going to be 53. And so again, plug it into your formula as always. And so we're going to say our arc length S is going to be the part over the whole. So we're talking about part of the circle, which is 53 degrees, out of the whole entire circle, which is 360. And then we have our normal circumference formula, so we have 2 times pi times the radius, which is 8. And make sure you can multiply it carefully for yourself. So I say, let's have 53 over 360, and times 2 times pi, so second, and then exponent, and then times 8. Get our nice clean answer. So we are going to have S is going to be equal to, or let's actually say our arc length of that section. So we're talking about HI. So HI, arc length, is going to be 7.4. And then we have those units, so we're going to say centimeters. And then the second one, it says find the perimeter of that section. So think very simply for yourself. Again, we're talking about, this section of HI. So what are these side lengths? Well, we know that these side lengths are 8, as the radius is 8, and then we have that this HI is 7.4. So again, add up all the sides. So we're going to say perimeter is going to be equal to 8 plus 8 plus 7.4. So we're going to say 16 and then 23.4 centimeters. And number 3, find that perimeter of section or sector KJ. So first I need to find the arc length of KJ, and then I can add up all the sides. So we're talking about this a little bit longer side KJ. It still has radius is 8, so radius is 8. The angle theta now is going to be 135. So make sure you can still plug those in. So I have, let's have KJ. So let me actually write it. Let me write it on over here. We'll say the arc length KJ. Make sure it's still on the screen. Yep. All right. KJ is equal to, let's have the part, which is 135, over the whole, which is 360, times 2 times pi times the radius, which is 8. So we're going to say KJ is going to be, let me actually do it like this, 135 divided by and 360, and then 2 times pi, and then times the radius, which is 8. So we're going to say about 18.85. So we're going to say this is 18.85 is that amount for KJ. However, make sure you're saying, okay, we're talking about the perimeter of this section. So we need to say perimeter is going to be equal to 8 plus 8 plus that 18.85. Add those together to get your perimeter, which we're going to say is 16 plus 18 is 34, so 34.85 centimeters. Again, make sure also too, if you need to, on the back bottom, you're able to check your answers using the possibilities below. And this should be, I think, a 3.9. I'll double check on that, but that should be 3.962. In case it got cut off, but we'll get to that in just a second. Okay. So now, closing out that first circle, as find the area of HK. So where is HK? Well, we're talking about this shaded amount in here. So if you need to redraw it for yourself, you certainly can, but we're saying, okay, we need to find this area. So make sure you have those units to the second power. So I find the area of HK, so I'm gonna say area is gonna be equal to the part, which is gonna be 99 over 360, because we have our angle theta over 360, times the pi times the radius squared. What's our radius? 8. And then raised to the second power. Please make sure you're not multiplying by 2, that's raised to the second power. So again, you type it in like this, so then 99 divided by 360 times pi, and then times the radius, which is 8, and then exponent 2. Again, make sure you just type it in as one line, that way it's nice and clean, that way you get a nice, simple answer. So we're gonna say about 55.3, or let's see, what does it have here? Yeah, it's 55.3, and then so 55.3 centimeters squared. Just gonna make sure you can see that for yourself very simply. Again, feel free to pause, ask questions as you need to. Please do ask questions, that way you're not lost for that quiz. All right, in number 5, it says find the arc length. So we're talking about a new circle. Notice how it has some different dimensions. And it's saying find the arc length of AB. So we have this section in red, that arc length AB is what we're looking for. But then it says in these problems, give all your answers in terms of pi. So that means just leave pi as it is. Maybe treat it as a variable. That's a little bit easier for you to do. It's pretty straightforward. So that means this, okay, if I'm looking for that arc length AB, again, I need, what's my angle? So I have R is 7, make sure it's on the screen, which it is. I have R equals 7, which is our radius. We have our angle theta. This is not a 0, this is the Greek letter theta, which is our angle amount in degrees, which is 120 degrees. And we're gonna say, okay, find that arc length. So I have 120 over 360. And then I'm saying times 2 times pi times the radius, which is 7. So what I'm going to do is I'm going to type it in exactly as it looks, except I'm not going to include pi because I'm just going to treat it as a variable. So I'm still going to have, times pi at the very end, but I'm just going to leave it as pi. So this is what I'm saying. I'm saying 120 divided by 360 times 2 times 7. So it has that value. Let me see if I can change. What I can also do is say this. I could say 120, let's actually do it like this, 120 over 360, that's the same as 1/3. So what I can do is I can write it like this. I can have 2 times 7 is 14, and then I can have it like this. I can have 14 pi over 3, since this is about 1/3, and then 2 times 7 is 14 times pi is how we get our answer. And then it says find the perimeter of that sector. So now that I can have those two together, again, real simple, add these like this. I'm gonna have 7 plus 7 plus 14 pi times 3, or excuse me, over 3. However, you notice I'm not gonna be able to combine these because I'm leaving these in terms of pi. So if this was a variable, I would say that I couldn't combine like terms, so I'd have to leave it like this. I'd say 14 plus 14 over 3 times pi. And then lastly, the area of that sector. It's going to say area is equal to, let's have 120 over 360. And then we have times pi times the radius squared, which is 7 squared. So do 7 squared, I have 7 times itself is 49. And we're going to say 49 over 3 times pi. So 49 over 3 times pi is going to be our area for that sector. Again, make sure you include your units so that way you know you're good for each of those. So then on the back, at the top, it has, this is a partial sector of a circle. So kind of if you need to kind of fill it in, that circle for yourself, feel free to, but we're just talking about this sector. So it says find the perimeter of the sector. So that means I have to first find that arc length. So we're gonna say R is gonna be 14. Our angle theta, excuse me, is gonna be 240. Make sure you can find that section, or excuse me, arc length. There we go, arc length. So we have arc length S is going to be 240 over 360, and we have times 2 times pi times the radius, which is 14. So this one I can type in because we are calculating it. So I have 240, 360 times 2 times pi times the radius, which is 14. So we're going to say it's going to be about 58.65, but if you notice, hey, that's not my answer. I'm saying this is just going to be that arc length. So I have that arc length S is 58.64, but I'm looking for the perimeter. So I need to say perimeter P is going to be 14 plus 14, because we're talking about this side length plus this side length plus this arc length. So those two added together plus at 58.64, and let's see, this is going to be 28, which is going to be 86.64, and then meters. So we're saying the perimeter around the outside of this circle, or sector of a circle, is going to be 86.64 meters. And then for number 9, it says find that area of that sector. So now we're talking about that inside amount covering that sector. So we have area is going to be 240 over 360 times pi times that radius, which is 14 squared. So what I can do is type it in like it looks, times pi times pi, nope, let's try it again, 240 over 360, and I have pi, and then 14 squared. So we're going to say this is going to be about, our area is going to be 410, and we're going to say 0.5, and then we're going to say meters squared, since we're talking about an area amount. All right, so now in this last section, a little bit trickier because it's asking for the larger arc length. And so when you think about that, if you're looking at this picture, okay, it gives us an angle of 45 degrees. It's saying, hey, this angle is 45, and that radius, so we know that the radius is going to be 36. But make sure you're reading that question carefully. It's saying find the arc length of the larger, so the larger arc. And what is going to be that larger arc? What do you think? Is it going to be this slice here, or is it going to be this outside amount? So notice how I'm talking about, if this is a slice of the pizza pie, we'd say that, hey, the remaining amount is going to be that larger arc. So we need to figure out what's that angle amount. Well, if I know that, a full rotation is 360 degrees, so let me actually write that. Full rotation is 360 degrees. And so I need to use that because I can say, hey, what's going to be, I kind of have this as the remaining arc, or excuse me, the remaining angle. What's going to be that angle amount? Well, I need to say that, hey, I have to take 360 minus 45 to get my larger angle. So I'm going to say this larger angle amount is going to be 315 degrees. So I'd say this angle theta on the outside here is going to be 315 degrees. So make sure you're using that very carefully for yourself. We're saying, hey, the angle amount is going to be 315. So I need to find the arc length of that larger angle, or excuse me, that larger section. So I have arc length S is going to be equal to, I have 315 over 360. Again, make sure you're using that 315 because we're talking about that larger amount. If it was asking for the smaller arc, you would say 45 degrees. So be very careful when you're plugging in those values. And then we have our radius, which is 36. Type it in exactly as it looks. I have 315, divided by 360 times 2 times pi, times the radius, which is 36. That's going to be, this arc length is going to be 197, and then we actually see that choice down there, 197.92 centimeters. So you're going to make sure you're using that list of answers for your checking. So okay, let's see, what do we have next? Find the perimeter of that larger sector. So we found that arc length of that larger sector. Now we need to find the perimeter, so we're going to add these together. So I have P equals, we're going to have 36 plus 36, because we're talking about these two side lengths, which are the radius. And then we have plus our section that we found, so 197.92. Add those together, so 72, and then we'll say this is going to be equal to 269.92. 0.92 centimeters is the perimeter around that larger arc. And then lastly, we need to find that shaded area that covers that larger sector. So this is going to be that very large answer. I think it's 39, but let's find out. So it says find the area. All right. So I have area is equal to the angle amount, theta, which is 315, excuse me, over 360. Again, part over the whole, times pi, times that radius, which is 36 to the second power, so exponent 2. So this is going to be equal to, let's have 315 divided by 360 times pi times 36 to the exponent 2. Make sure you type it in. It was 35. Oh, my bad. So this is 35.62, and then 5.7. So 3,562.57 centimeters squared is going to be the area of that circle. So decent sized circle for that 1 centimeters squared. And get used to using that pi button when it asks for it. Real simple for yourself. Again, make sure you can pause, rewind, replay any of those items for yourself. That way you can ask questions. If you can hear me and you hear this, please come up to me and I'll give you a bonus point for just being able to listen to me the whole way through. And as always, super slam that subscribe button.